Alright, time for another math easy solution. Here to discuss exact trigonomic ratios, and we'll look at basically these 0, pi over 6, pi over 4, pi over 3, and pi over 2. These are radians. These are, if you don't know what they are, you can see my other video on radians. So basically these are just angles, this corresponds to 0 degrees. This is 30 degrees. This is 45 degrees. This is 60 degrees. And this is 90 degrees. Well, from these angles you could get exact ratios, exact for sine, cosine, and tan ratios. Yeah, you can see my other video on what these are, what the definitions are. But I'll show you. So let's say we'll start off with the 0 degree. This one, if you just have a regular, just regular like this. This is x. This is y. Doesn't matter. Yeah, it's a horizontal line. If you have a triangle like this, this is called this opposite. This is hypotenuse. It's adjacent. You can see my other video on. I define this better. So this is what this is called. This is 90 degrees. This is an angle. So when this is 0, basically this is a horizontal line. So this goes to 0. So OP goes to 0. So it's gonna be a horizontal line. Okay. So let's say let's say this is length 1. This is when so this is OP and this is would be A. They equal this is hypotenuse. Yes, and OP is here, OP, and this equals 0. So from these you get exact ratios for sine. Sine 0, this is just the opposite over hypotenuse. And this is just 0 over 1, and this is just 0. So that's exact ratio. And then if with cosine 0, this one is just equal to adjacent over hypotenuse, and this one, you see my other video on these definitions. This is basically the definition of it. And this one will just equal to 1 over 1. This is equal to 1. So these are just exact. You don't need a calculator or anything. And then tan 0. This is just this one's actually if you were to do it, this is what's it called? This is hypotenuse. No, this opposite over adjacent. This is also going to be 0 over A is 1. So it's 0. So that's all it is. Alright, so now let's look at pi over 6 and pi over 3. These ones are actually tricky. So let's look at pi over 6, pi over 3. This is corresponding to 30 degrees and 60 degrees. Okay, let's draw a isosceles triangle right here. I'll just grab one from here. Okay, we'll just make one like this. Okay, we'll just make that. I'll just even make it a bit bigger, so I could write it in, because I got sometimes messy writing. Alright, so let's draw this. Let's cut it in half. Okay, and let's say this is length 2. This is length 2. These are all length 2. So this is from all the way this is length 2. If you cut in half, this is going to be length 1. This is going to be length 1. And if you know that a isosceles triangle, this is basically 60 degrees. 60 degrees. And this is 60 degrees. You can see my other video on why this is like, because all the angles add up to this goes sum. This is sum. Sum of the angles, basically inside the triangle is called this angles or whatever in triangle equals 180. And then so if it's isosceles, all the exact sides, all the angles are gonna be the same, and 60 times 3 equals 180 degrees. Alright, so we'll have this. And this one you could find this by Pythagorean theorem. You can see my other video on it. This one will just use Pythagorean theorem. And this is we'll just go a squared plus b squared equals c squared. C squared is hypotenuse, and in this case we'll just call this let's call this x. So then this is basically 1. We'll just call this a is 1. So go 1 squared plus 2 squared equals x squared, and then this is my bad. Sorry, I made a mistake. The x is actually so this one would be one of these. So the 2 is c. So we'll go 2 squared And then a is, we'll just go 1, let's say plus x. Let's call it x squared, and if you solve for x, when x would equal 2, yeah, this is square root 4 minus 1 is plus or minus, so then you'll get plus or minus square root 3, but in this case it's all positive, so we'll just go with square root 3, so that's what it equals. Okay, so now we have, we have exact ratios. If this is if split in half, this angle is 30 degrees, and this is 30 degrees. We'll just cut it in half. So from this, we'll just we'll get half of the triangle. So we'll get the half of the triangle from what we just derived. So we get, if we draw it like this, or something like that, this is 1, this is 2, my bad, no, this one's 1. Yeah, this one is just, this is root 3, so we'll just call this root 3. And this is 30 degrees, this is 60 degrees, or this one is just pi over 3, and this is degrees, this is pi over 6 radians. And then from sine would just be sine of, we'll call it pi over 6, as it's 30 degrees, equals to, well, if you look at the opposite of this one would be 1 over, so this is OP over H. In this case, OP is 1, or opposite. This is opposite, and this is hypotenuse. So we'll have 1 over 2. So that's an exact ratio. And then if we were to go sine, or not sine, cosine. Cosine, we'll go cosine of pi over 6. This one is equal to, adjacent over that. And in this case, if we're looking, this is a reference angle. So we're looking at this angle first. So this one, well, adjacent is root 3, and this one's over 2. Then if we go to tan, this is just opposite over adjacent. So we'll go, opposite over adjacent, so this over that, so it'll be 1 over 3. And then if we were to go, so this is for 30 degrees. Or pi over 6. So now if we were to go from, look at 60 degrees as the reference angle, or pi over 3, and then sine of pi over 3 equals, well, basically opposite over adjacent, root 3 over 2. And if we were to look at cosine, is adjacent over hypotenuse, so this is 1 over 2. So there's 1 over 2. And tan, this one is just going to be equal to tan of pi over 3 equals to, opposite over adjacent. So root 3 over 1, or just root 3. So basically these are all exact ratios. So these are exact ratios. Okay, so now another one, if we were to look at, let's say pi over 4 or 45 degrees. So this one, notice it's 90 over 2. And if you were to draw 90 degrees, let's draw a box. This is to derive it. We'll get a box. I'll just draw a box right here. Let's say a square, or a square. We'll call this length 1, length 1, length 1, length 1. And this is 90 degrees. So just a regular square. Now if we were to cut this exactly in half, so this one now it's 45 degrees, we just cut it in half, and this is a right angle, this is a right angle. So now this length, using Pythagoras, this is c squared equals to 1 squared plus 1 squared. So then we'll just have, then we'll solve for c will just equal to plus or minus root 2, and then we'll only look at the, because negative doesn't make sense in this application, so we'll just look at root 2. So this is root 2. So there you go, we have all the sides. That's all you basically look at when you look at for trigonometry ratios. So we get this. So now we have for sine of 45, or we could pi over 2 is equal to 1. This is a reference angle. This is opposite. So this is OP, and this is A. That's H. So basically, yeah, this would be 1 over root 2. And then this one would be sine, or not sine. Okay, yeah, this is cosine 45. As this one, again, a is 1, so 1 over root 2. So this is the same. Cos a. And the tan would just be equal to, let's say, pi over 4. Doesn't matter. Yeah, tan would just be equal to 1 over 1 or 1. So yeah, we have exact ratios for this. And then the last one we want to look at is just, yeah, basic. Yeah, okay, so the last exact ratio I'm going to look at today would just be for, let's say, pi over 2. This one's just 90 degrees. And it's very similar to the horizontal line. So instead of having horizontal, now we just go straight vertical. And then if we look at an angle like this, or actually let's draw it like this. If you have an angle like this, this is theta. So basically, yeah, as you rotate this all the way to 90, this is 90 degrees. And that's usually how it's drawn. So if you rotate all the way here, this will have a straight line. Adjacent equals 0 in this case. And this is h, this is OP, they equal 1. So let's say they equal the same. So let's say we have a length. We'll just draw a line here. This is length 1. Yeah, this is a is equal to 0. And then, yeah, so basically it's similar to that other horizontal line, except it's just up there. So sine would just be sine of 90 degrees equals 2. What is that? Opposite. Opposite is OP equals H equals 1. So opposite is equal to, we have 1 over 1 equals 1. Opposite of hypotenuse. Cosine of pi over 2. Using interchangeables just so you know it means the same thing. In the calculator you would have to put on the degree mode or radian mode to get the right answer. So adjacent is 0, this is 1, this hypotenuse is 0. Tan of pi over 2, this is equal to adjacent. Oh no, opposite over adjacent, and this one's equal to, basically, opposite is 1, and this is 0. This one actually is undefined. This goes to infinity. So yeah, if you were to actually draw it, it would look, yeah, this one's actually infinity. So basically, yeah, you'll have that. So infinity or undefined. I'll show you how the graphs look in another video. So yeah, this one's actually interesting. Yeah, because that's basically what it is. You have opposite, and so you have 1 over 0 is going to be undefined. Okay, here's a summary table. So yes, here's a quick summary table. Let's write this down. Summary table of the ratios. Let's write this down. Yes, so here's for 30, 45, and 60. This is a quick one off the internet. But yeah, one thing you have to note this how this looks different from our, say, sine of 45, which is we got 1 over root 2. They actually equal the same thing. If you look at, I'll write it down here. So we had sine 45 degrees equals 1 over root 2. Yeah, this is written. Some people write this here. They want the square root on top for some reason, and this one's equal to, actually, if you were to let's just times the top by square root of 2 and times the bottom by square root of 2. So then we'll have square root of 2, and then this is square root of 2 times square root of 2, and this equals square root of 2, and this is square root 2 times 2, and this is going to be just square root 2 over, yeah, this is square root of 4. I'm just going with the long way. This is square root over 2. Yeah, so basically they're the same thing. So thus, yeah, 1 over square root 2 equals square root 2 over 2. So that's what they wrote here, or you could do, or 1 over root 2, or 1 over root 2, and then so on. Yeah. So that's what some do and whatnot. So yeah, this one too. This one's just 1 over square root 3. Okay, so yeah, let's make sure that one tan 30. Let's go back to that one. If I was right. Yeah, so tan 30 or pi over 6, 1 over root 3. So it's the same thing. And yeah, this one, for if you were to add the 0, I'll just add a 0, 1, and the 90. And then let's go here. 90 degrees. I'll just add this quickly. Yeah, so here I just add these really quickly. This is, yeah, for 0 degrees, 0, 1, 0. So yeah, here's a quick table if you ever want to look at what the ratios are. Well, that's it. Well, thanks for tuning in. Hopefully you learned how to basically add how these are actually derived. If you ever come across in math class, here's a quick way to derive the 45-degree exact ratios. And this one's actually I had some trouble actually figuring out the proof for this. This is a pretty good proof. You just get an isosceles triangle. Let's call this isosceles. Isosceles triangle. Something like that. I probably spelled it wrong, but and whatnot. I might have to do a video on the isosceles triangle later. But anyways, thanks for watching. And this one you can see another video. I show why this has to be it. And from there you could easily deduce that it's 60, 60, 60 if it's all the same angles, because they're all the same by symmetry. Well, thanks for tuning in. Hopefully you learned about exact ratios and use them in practice. Actually, instead of using a calculator, you can just use these exact ratios. Well, thanks for tuning in, and tune in for another Math Easy Solutions.